Hi there guys, welcome back to my channel. Today I would like to talk about a little experiment about random numbers in Matlab. So as you might know, in many programming languages such as C++ or JavaScript or Matlab itself, there is a built-in function called rand or random, which allows you to generate a completely random number between 0 and 1. So for instance, let's call this number A. This is gonna be the result, and you can try this again and again. The number will be pretty casual, pretty random. Today I would like to show you an idea of mine to emulate this function, but not using the command rand, but some mathematics. So let's set to a plotter and discuss. Many of you might know the function sinus of x. I will plot this here. It's just a wave-shaped smooth curve, as you can see here. Pretty nice, pretty simple. But what happens if I had 1 and divide everything by 2? Let's see. The curve stretches, okay? But more importantly, now it's limited. Its values goes from 0 to 1, and it's just a nice adjustment. But I'm not satisfied yet. I would like to generate random numbers, okay? So I would like to increment its frequency to 10,000. See what happens. The computer sorta glitches because now it appears like a black stripe which covers everything from 0 to 1, and this is just what I want because there is an equal chance to get any number from 0 to 1. The function will just squeeze out randomly numbers. I wrote down in Matlab a code to see if this works. So right off the bat, let's set to that. I call the function random, which starts from a starting point called x with 0. It doesn't really matter what point you just decide, but the numbers will be generated randomly either way. So I define here a matrix which is 2 to the power of 16th number full. It starts from zeros though. Then I'm gonna exploit this succession, this series. So the new term, the new value of my series depends both on the previous value and on the initial value. This is just to make it more random. Then if my new value is from 0 to 0.5, the pixel will be painted in white. Otherwise, if the new value is from 0.5 and 1, the pixel will be painted in black, because 0 is black, 1 is white in this case. Then it's gonna show the whole map. Let's try this out. So random of, it's the same. This is gonna be the result. You see? The black squares are distributed randomly throughout the map, and it's like a small whole televisor, right? Let's see what happens if I use the actual rand function here. So I built down another code in a similar way. This time the window will be called function rand to distinguish it from the previous figure. And the value is sorted randomly with rand. Let's see what happens. So it's pretty nice, isn't it? My function is similar to the random one. You can compare them. So this is mine, figure 1, and this is the random function. You cannot distinguish them so easily, can you? So this is just a perfect experiment for a head or tail game. You have the same chance of getting head or tail, and this works. So let's close them and try another thing. I would like to test if my function is pretty random throughout every set of values. So I will comment this and uncomment another block I wrote before. Let's describe it. So this time the A matrix is gonna be multidimensional, and every pixel is gonna be colorful in a different way. The series is the same, but this time there are many sets. So if new value is from 0 to 0.25, the pixel is gonna be red. If the value is from 0.25 to 0.5, the pixel is gonna be green, blue otherwise, and gray. Let's try this out. Let's see what happens. So random of, you know, what do you want? This is the result. So at first glance it seems like everything is random, right? But if you pay more attention, if you look closely, you will notice that there are many reds and grays and very few of greens and blue. So this is just not what we want. This is not equally distributed. Let's compare it with the random function, shall we? So in a similar way I will comment this out and uncomment another block. So same structure, same multidimensional matrix, same values, okay? But this time I will use the random function here, the rand. Let's paint it. Oh, so as you can see, there are many greens, many more greens than before, and blues as well. So the rand function is more random, is equally distributed than mine, and it's better after all. This can be explained with the fact that the sinus just rises very fast from 0 to 1, but then it's so slow that the numbers are captured in low levels like a pit, or the high levels like a peak. So there are many greens, many reds and grays, which are the zeros, close to zeros and close to ones. Let's try one last thing. Let's count all the pixels. So I would like to slightly change it. I will not paint anymore. I just count them. I just count the pixels. So let's try another time random with the same starting point, just to be clear. And I will call this matrix generated A. Okay? So there is a small issue here. Maybe I didn't I didn't save the function. Sorry again. So the A matrix is now generated. Let's count all the green pixels with this command. As you can see, the total green pixels is 10,033. There are few. But if I check the B matrix out, so the matrix generated with the rand function, the result is going to be a little bit different. There are many more greens, as you can see. So these are the greens pixel generated with the rand, and these are the green pixel generated with my function. So it's still improvable. The sinus is not the perfect choice, and I hope you will think about that. I will post the code in the description so that you can custom as you want, that you can adjust it or think of a better solution. It's pretty complicated at first glance, but it's simple once you're in. So this is just reiterated in a way that the first plan is for the red, then for the green, then for the blue. Leave a like and a comment. Let me know if this is interesting enough to proceed to release other videos in the future.